Okay, everybody. This is just a quick lesson. It's really just I'm giving you. I'm going to go through a practice quiz for VLO 1-4. Okay, so 1-4 covers dimensional analysis. We get into the concept of using Avogadro's number, but kind of more importantly, setting it up using dimensional analysis. The concept of molar mass and how to use that in dimensional analysis, and then maybe how to take a measurement like density and use it as a conversion factor. So it's all about dimensional analysis, but there's a lot of little things in there that you need to know. Not to mention all the metric equalities that you're responsible for from the prefix system. So from 1-3. All right. So you know. So for this quiz, when it says on the unit test, if it says show your work and use dimensional analysis, you need to show the setup. So you might know mathematically what you need to do to get the right answer for the question, but if you're told you have to show the setup, you got to set it up. Now, again, I use the kind of T-chart method. If you like to use ratios and the multiplication sign, that's fine too. But you still have to show your work when it asks you to. All right, so I just have a practice quiz. I'm going to go through it, show you how to answer it, and hopefully, it helps you when you have your 1-4 in-class quiz. All right, so let's go. And you will get a periodic table. So, if you need to use the periodic table to look up molar masses, you get one. You just got to know how to do it. All right, so here we go. All right, so here's a practice quiz. All right, so it says, here's an equality, 100 centiliters equals 1 liter, and it says create 2 conversion factors from this equality. And so remember, all we have to do is this over that, or that over this. So let's go to the answer here. All right, so I could say 100 centiliters over 1 liter, or 1 liter over 100 centiliters. All right, next question. They don't necessarily give us an equality. They give us a unit, meters per second. And so remember, it doesn't matter what this unit is, and it doesn't matter what this unit is. If you have a unit, something over something else, so M per S, this could be X and that could be Y, X per Y, whatever, grams per mole, like the units for molar mass, we can make a conversion factor. So the way to interpret this is make it an inequality. What we're saying is 3 times 10 to the 8 meters is equal to 1 second. So it's this many meters over 1 second, or 1 second over this many meters. And so those are our 2 conversion factors. So we could use this conversion factor, or this measurement of speed in this case, to convert from seconds to meters or meters to second, depending on what we were given. So how that would look on your quiz, I would just say 3 times 10 to the 8 meters per 1 second, or 1 second over 3 times 10 to the 8 meters. Now I said 1.0 seconds, and that's an S there, sorry. It looks like my G as well. But I said 1.0, just because I'm maintaining sig digs, but you don't need to. You could just have 1 second and 1 second on top here, okay? And then you have to know Avogadro's number. You have to have that memorized. So that's 6.02 times 10 to the 23rd. And so this is a 23. When I first glanced at it, looks like a 5 or maybe a 7, I don't know. But that's to the 23rd power. So Avogadro's number is 6.02 times 10 to the 23rd. Okay? And you just have to have that memorized. Okay? Now, we're going to use Avogadro's number here in a second in a calculation, but you got to know what it is. Okay? So the next question, it's just asking you to calculate the molar mass of sodium sulfide. And remember, I gave you sulfide. I gave you the formula, right? At this point in chemistry, you don't know how to get the right formulas for certain things. Hopefully you know water is H2O, and maybe you know carbon dioxide is CO2. But I wouldn't expect you to know the chemical formula for sodium sulfide. But there it is, Na2S. Now, given the formula, you got to be able to calculate this compound's molar mass. So the way to interpret this is you got 2 sodiums, 2 NAs, and you got 1 sulfur, okay? And you're going to have to reference your periodic table. So if we find Na on our periodic table, we got 22.99. Remember, we're going to round to 2 decimal places. So this number rounds to 22.99. And then if we find sulfur, we got 32.06. Now, some other periodic tables that you might use might say 32.07. It doesn't matter if you're off by a hundredths place or something. Just use the number that you have on your periodic table. So one of these and two of these. So it would be 22.99 plus 22.99 plus 32.06. So that's all you'd have to do to add it up. Okay. So again, 2 sodiums, 1 sulfur. So 2 times sodium's molar mass plus 1 times sulfur's molar mass. We add them up, and I get 78.04. Now remember, it says include proper units here. The units for molar mass are grams per mole. So again, here, just like up here, right? We could use this as a conversion factor. So I could use this. This would be my conversion factor to convert moles of sodium sulfide to grams, or grams of sodium sulfide to moles, right? So I could say 78.04 grams for over 1 mole, or I could say 1 mole on top over 78.04 grams. Okay, so now let's go to the actual dimensional analysis problems. Okay, so it says in the space provided, it should say provided, or in the space provided below, show your work using dimensional analysis, then put your final answer, including units and sig figs. Okay, so make sure you have the right number of sig figs in your answer and make sure you're including units. And the question is, how many iron atoms, okay, so iron particles, are in an 8.78 mole sample of iron? So we got 8.78 moles of iron, which is Fe, okay, on your periodic table. So we'll look that up. And we want to go from moles to atoms, particles. Okay, now don't get confused. You don't need molar mass here. So I don't need to go to iron and get this number. That number, the molar mass of iron, 55.85, that's only there if I have moles and I want grams, or I have grams and I want moles. That's not the case. Here, I have moles and I want particles. So the number we used for particles is Avogadro's number. Okay, so remember what Avogadro's number really means. Okay, it means you have this many atoms equals 1 mole. So we could say 1 mole over that many atoms, or we could say that many atoms over 1 mole. And that's what we're going to do in this problem because we have moles. So to show your setup, you start with the measurement you're given, 8.78 moles. Okay, and if you want to be specific, you could say of iron. Okay, and then we're going to say Avogadro's number on top over 1 mole, and the reason why we're doing that is we're canceling out moles to get to atoms or particles. And so now we just do the math. We take this number and we multiply it by this number and we divide it by this number. Since this number is 1, we don't have to do that. So 8.78 times 6.02 times 10 to the 23rd. Make sure you know how to enter that into a calculator properly. And sig digs would be 3 because the number of moles I was given has 3. Avogadro's number has 3, so I'm limited to 3. And the proper units, you could say particles, but in this case, because iron is an element, the unit of an element is an atom. So 5.29 times 10 to the 24th atoms would be my answer. But I need to have the setup. Okay, and again, this should say provided. I'm kind of annoyed now. All right, so in the space provided below, show your work using dimensional analysis, then put your answer, including units and sig figs, on the line provided. And this is asking, what is the volume in liters of a 2,500 gram sample of copper? And the density of copper is given to us as 8.6 grams per liter, or milliliter. Oof. Okay, so that's key right there. Our unit for volume in the density measurement is milliliter, but our unit for volume that we're looking for is liter. So you can't just go D equals M over V and then solve for V, right? And say V equals M times D. Because if you just use your equation, right? If you do this times that, volume equals mass divided by density. So if you do mass divided by density, you're going to get the volume, but the volume measurement you're going to get is milliliters, but the question's asking for liters, all right? And then another thing is, I don't want you to use the equation. I want you to do dimensional analysis, right? I want you to show your work right here using dimensional analysis. So what are you going to do, all right? Well, first, understand that density is given to us. That's a conversion factor. Okay, we can make it an equality. We can say 8.6 grams of copper equals 1 milliliter of copper, but then we could say, make that into two conversion factors. We could say 8.6 grams of copper, right? So that's the equality I get from that unit of density. And I can say this many grams of copper over 1 milliliter of copper. I can say 1 milliliter of copper over 8.6 grams, either one, just depending on what the question's asking about, okay? And then the other equality I need to know to this question is I need to know how to convert liters to milliliters to liters. And so you got to know that there's 1,000 milliliters in 1 liter, right? So the setup would be, you're not starting with the density. Density is going to be a conversion factor. You're starting with grams. That's what you have. You have grams and you want to convert it to liters. So start with the unit you want, 2,500 grams, okay? We would use our density as a conversion. In this case, we would put 1 milliliter on top and 8.6 grams on the bottom to cancel out grams. And then we would use our metric system equality that we need to know, and we would put 1,000 milliliters on the bottom and 1 liter on the top, again, because we want milliliters to cancel out. So that's our setup, and then mathematically, we're just doing 2,500 divided by 8.6 divided by 1,000. Okay, that's what we're doing. And so when you do that, you get 0.29, and the reason why I'm rounding to two significant digits is because my mass had only 2. Okay, the density had 3, the mass only had 2. Remember, metric system equalities are exact, so that doesn't limit us. So this had 2, this had 3, so I'm limited to 2. And you don't have to put it in scientific notation, so you could say 0.29 liters, or you could say 2.9 times 10 to the negative 1 liters, but that would be our answer there. Okay? So again, you need to do the setup. If I'm telling you to do the setup, you have to do it or you're not going to get full credit. All right? So that's just a quick little practice quiz. And, you know, expect the quiz that you're going to see in class. Very similar, very similar. So if you understand everything that was going on there, you should be in great shape. If you don't, you need to come ask questions. Okay, I got a lot of people, you know, that might be lost. I'm looking at their Schoology assessments and they're not 100%. They're not, you know, it looks like they might not be getting it, but they're not coming to get extra help. And when they're in class, they're not asking questions. So you got to figure that stuff out. So hopefully this video helps you. And hopefully when you take the quiz next class, you're ready to roll. All right.